Hello and welcome to today's lesson. Today we're going to be talking about matter. We're going to describe matter and we're going to see what its properties are. Now, what is matter? Matter is anything that has mass and takes up space or volume. So if it takes up space, that means it has a volume. Now, matter is the stuff of which everything is made up of. For example, take a deflated balloon. Compare it, now inflate it, like blow some air into it, and you're gonna see that that balloon gets bigger and bigger and bigger. Well, guess what? That balloon now has more volume because it's bigger, it takes up more space, and it also has more mass than when it was deflated because you actually added air into the balloon. Moving on, we also have volume. Now we're gonna define volume and mass too. They're important to describe matter. So volume. Now volume is the space the object occupies. I already talked about the inflated balloon, how it's bigger than the deflated balloon. Now volume is a measure of the size of a body or region in 3D space or three-dimensional space. So I put some examples here. For example, if you have a solid object, like let's say a book, how do we know the volume of the book? Well, we actually measure the length, width, and height of the book. So if I were to draw the book, alright, so let's say this is my book. Alright. And we're going to put chemistry here because we're learning chemistry. All right, and these are the pages. Okay, so if we were to measure the volume of this book, we would actually have to measure the height, which is this. So that's height, or let me write it better. Height, which is from here to here. Now the length of the book, this is the length. That's the length of the book. And we also have to measure the width of the book. So, look at the book. You're going to measure how tall it is, how long it is, and how wide it is. If we have a box, so let's draw a box here. Again, we're going to measure the height, the length of the box, and the width of the box. So here we're going to measure this face, the height and the length, and then we're going to see how far back that box goes, and that is the width of the box. Okay. Now, for liquids, we actually need to use graduated cylinders. So, graduated cylinders to measure the volume of liquids. What is a graduated cylinder? Okay, so let's not talk about the lab now. Let's talk about the kitchen, because we use it practically every day. Anybody who cooks, they use something to measure the liquid. So you might have seen your parents or somebody who was cooking and then they wanted to measure some milk, some water, whatever. They put it in a measuring cup. And that's how you measure liquids. So let's go to the right. Let's erase all of this. Okay, so you have a measuring cup. Let's draw that measuring cup right here. Alright. So this is the measuring cup now. I'm going to pour some liquid in here. And it's going to fill up, let's say about to there. You're going to see that, for example, here it measures 2 cups. 1 3/4, or let's say 1 1/2. 1 1/2 cups. And then here where that liquid reaches, that's 1 cup, and then half a cup right down here. Okay, so you see these things? Well, that's how you measure liquid. Same thing in the lab. In the lab, you're going to have a graduated cylinder, which is pretty much like a measuring cup, except it's going to be like a really long and tall piece of a cylinder, a long and tall cylinder, and it's going to have lots of measurements on the side. And then wherever the meniscus reaches, so the meniscus is like that little topmost part of the water. That's the meniscus. Now you're gonna have to get down on eye level to see where it's at. All right. Now for gases, you measure the container that gas is sealed in. So just take anything, for example, Tupperware, whatever. And you can measure it like you measure the book. It's easy. Oh, snap. Now, mass. Mass is the quantity of matter contained in an object. This is a fundamental property of an object, and it is not affected by the forces that act on the object, such as the gravitational force. So, for example, if we have a marble versus a ping pong ball, a marble is usually heavier than the ping pong ball. Like if you put it on a scale, you can see that the marble actually outweighs the ping pong ball. Why? Even though the ping pong ball is bigger, the marble has more mass because it's solid, whereas the ping pong ball is actually hollow inside. Now the mass is measured in a balance. It's usually expressed in grams. We're going to talk about that later on. Now this is extremely important. Mass is not weight. It is not the same. Although mass is related to weight, they are not identical. Why? Because mass does not never ever depend on gravity. The mass of an object will never change. If you take it from Earth to the moon, to Mars, to wherever, it won't ever change. Whereas the weight, it is dependent on gravity. Therefore, a person will actually weigh 6 times more on Earth than they will in the moon. So let's say a person weighs 100 pounds. A person weighs 100 pounds on Earth. They will actually weigh 60 pounds on the moon. Now, the force of gravity is directly proportional, or the force of the gravity exerts on an object is directly proportional to the object's mass. Therefore, if we have an object, if we increase gravity, we increase, not mass, the weight of the object. That's why they're directly proportional, because these two arrows point the same way. They don't point in opposite directions. So if we were to increase the gravity by 2, that means we also increase the weight by 2. Alright, so moving on to properties of matter. Now we're going to talk about 4 different things. We're going to talk about physical properties, chemical properties, intensive properties, and extensive properties. First of all, physical properties. Physical properties can be determined without, keyword right here, without changing the nature of the substance. We can list things such as color, the state the object is in or the substance is in, as in if it's a solid, a liquid, or a gas, or the density of an object. But what is density? So density Density of an object is the mass of the object divided by its volume. So down here, I put the formula. Density equals mass over volume. If you want to abbreviate that, we would put M for mass over V for volume. Now, density is, let me erase this so you can see better. So density is always the same no matter what the size of the sample is. And if you don't believe me, let's go down here and look at this graph, this beautiful graph. Now this graph represents the mass, right here, the mass versus the volume for a sample of aluminum. So how do we know if what they say is true? So if it's always the same no matter the size of the sample, that means that as the mass increases, the volume also increases. That means they are directly proportional. Let me see if I can, okay, there we go. Proportional. Again, as I said, as I increase mass, I also increase the volume also increases. And how do you know? Because look, that line is going up steadily, like a ramp. When it goes up like that, that means they're directly proportional. So if we were to take I don't know, a random point. So I'm gonna put, okay, this point's good. So if I take this point, which we know is 30, the mass is 30, and then if we go down here, let's see how much is the volume. The volume would be 11. So 11 and 30. Now we're going to go to the right. Remember that density equals mass over volume. Now, as I said, the mass, we saw that it was 30. So I'm going to write here M for mass equals 30 grams. Why did I put grams? Because look here, let me zoom in so you can see. So, oh, there we go. So it says the mass. In parentheses, we have a G. That means the unit for mass is grams. Okay, now zooming out. We're going to go again to the right. And then for volume, V for volume, we have that it was 11. So 11 centimeters cubed. When you see a 3 in superscript like that, that means it's cubed. How do we know it's cubed? Same thing. We zoom into this axis, we can see that the volume has in parentheses centimeters cubed, which means that that is the unit for volume. Alright, so now that we have mass and volume, we can easily calculate density because all we have to do is substitute for mass M right here and for volume right here. So I'm going to put D for density equals 30 grams because of the mass right here over, because we see the over right here on the equation, over 11 centimeters cubed for the volume. So we divide that. So 30 divided by 11, we have 2.73. We're going to round up. We have 2.73. Now we need units. We always need units. And guess what? Here we have the unit G and the unit centimeters squared. Just as it was written there, we're going to write it here. So grams over centimeters, not squared, I'm sorry, cubed. And that is our density. If we were, so that aluminum, actually the density of aluminum is 2.73 grams over centimeters cubed. If we were to calculate every single point on this graph using the exact same method, we would see that it will always be 2.73, or really close to it. So if we were to take this point 2, we would have to do this again. But we're not going to calculate it now. We're going to move on. So here, let me zoom out now. This, what you're seeing on screen right now, that is a graduated cylinder. Now, what does it tell you right here? That as you go down on this graduated cylinder, the substances, they increase in density. So that means that I'm not gonna look at the cork, the paraffin, or the rubber. I'm gonna look at the liquids only. So we have ethanol. So ethanol is alcohol, drinkable alcohol, what your parents or family members drink. Everybody who's over legal age. So we have ethanol, oil, water, and glycerol. So what this means is that ethanol is actually less dense than oil. Now, oil is less dense than water. That's why oil is on top of water and ethanol is on top of oil. And if I were to have ethanol and water together, ethanol would go on top of water. Alright, so glycerol. That means that water is less dense than glycerol. So things that float on, let's just take water. So if something were to float on water, then that means it's less dense than the water. That's also kind of dependent on the shape of the object. Like, for example, a boat. We're not gonna delve into that. Think about ice. Ice floats on water. That means that ice, even though it's a solid, is actually less dense than its liquid form. And you're gonna learn later on how extremely important it is that ice floats. Alright, so the chemical properties. Now, chemical properties, they are a property of matter that describes a substance's ability to participate in chemical reactions. They can only be identified by trying to cause a chemical change. So, for example, we have to try. Try is the key word here, to cause a chemical change. So, if it undergoes a chemical change, that is a chemical property. But if you try to force it to cause a chemical change, but it does not want to, guess what? That is also a chemical property. That's very important. Now, you're going to see that in this example right here. So, iron and oxygen versus gold and oxygen. So, iron will rust. Rusting, remember, that is a chemical property. However, gold will not rust. It will actually stay the same. It will not tarnish either. That is a very important property of gold, and that's why gold is so beautiful and people buy it, and there's a whole commerce around it. But I digress. Let's move back. Okay, so another example, we have some silver compounds, and they react plus light. So that means some silver compounds, they actually react to the presence of light. Now, this was actually used in before digital photography was available, when there was analog photography, to reveal the photographs. So if you've ever in your life, maybe in a movie or something long ago, have heard somebody say, if let's say they were using not an SD card or anything in their cameras, but maybe a roll of tape, for example, or photograph film. So if somebody ever said, do not open the the back of the camera because you're going to ruin the photos? Yes, you're going to ruin the photos because they react to light. So that's why the photographs are actually revealed inside what were called dark rooms. There's very few in existence today, but they still exist anyway. So they're dark because the silver compounds in the film react to light. Also, some of you, maybe even some of you, may have transition lenses on right now. So transition lenses, they have silver compounds too. So the silver compounds are actually what makes those lenses go dark when they are exposed to light. All right, so moving on to intensive properties. So intensive properties, they do not depend on the amount of the sample. So this property does not ever change when you take away some of the some of the same. No, I wrote that wrong. I'm sorry. Some of the sample. So intensive properties include color, odor, luster. So luster is how shiny a metal is. Malleability. That also applies to metals. So malleability of a metal determines how easy it is to bend a metal. Malleability may also be used in rubber compounds or stuff like that. Just think of malleability as how much you can bend something. Now, ductility, that is actually the a metal property, because ductility represents how much you can pound that metal and turn it into like a really, really fine sheet without it breaking. That's very important because some metals are actually brittle and you can't pound away at them or they'll break. Conductivity, that is how well a metal is able to conduct electricity. There's also hardness of the sample, the melting and the melting/freezing point. You're gonna learn later on. They're the same, just in reverse. We also have the boiling point of the substance, the density of the substance, and the temperature. All right, so remember that I said that density equals mass over volume. Now, it doesn't matter if you have a small sample of, let's say you have aluminum. Let's say you have a little block of aluminum versus a huge block of aluminum. The density never changes because both mass and volume are directly proportional. So as you increase the volume, you increase the mass, and vice versa. As you increase the mass, you increase the volume. Now, extensive properties. So extensive properties, they do depend on the amount of the sample. It's very important. They are dependent on the amount of sample. This property changes when the sample, or when the size of the sample changes. So mass, volume, length, total charge, or energy. We're not gonna look at these last two, so don't even pay attention to them right now. You're gonna learn later on how they are actually extensive properties. But mass. So if you take away or cut away at the sample, you're actually taking away some of the mass. That's why it's dependent on the size of the sample. Volume, same thing. If you make it smaller, you're reducing the volume. Same thing with length. You make it smaller, you're reducing the length. All right, so we finished with this lesson. We're gonna look at some exercises. Now, try to do these 6 exercises before I discuss them. All right, so what were 2 physical properties that characterize matter? So we can think of our favorite one, density. Learn that one, folks. It's gonna come up again and again and again. A second one would be color. The color of the object does not change, therefore, or, I mean, it doesn't need to undergo a chemical reaction in order to determine the color. You just know it by looking. Now, next one. How does mass differ from weight? So remember that one. Remember I said mass did not rely on gravity, but weight does. Weight does. That means, again, mass does not rely on gravity, but weight, or eight, but weight does. That means that as you increase the gravity, you increase the weight. Because they are directly proportional. Mass, remember that it doesn't matter where in space you are, on Earth, on Mars, on wherever in space you are, it never changes. You never change how much you have in you. Alright, so moving on. Next one. Distinguish between a physical property and a chemical property and give examples. Give an example of each. Remember that a physical property is a characteristic of a substance that does not involve a chemical change. An example of this would be density. Again, density, or color, or hardness, etc. Now, a chemical property is a property of matter. Let's write that. A property of matter that describes a substance's ability to participate in a chemical reaction. An example of a chemical property. So an example of a chemical property would be iron, or let me write example. Example would be iron reacting with oxygen to produce rust. Alright, moving on to the next question. Why is density considered a physical property rather than a chemical property? Well, you don't need to react a substance to determine its density. So that's why. So you don't need to react a substance to determine its density. Alright, so next question. A block of lead with dimensions of 20 centimeters by 8 centimeters by 0.350 centimeters has a mass of 600 grams. Now calculate the density of lead in grams over centimeters cubed. Now it's important that you pay attention and follow along. Alright, so we have these dimensions and then this, the amount of the mass. So we're gonna do this little table. We're gonna have our given numbers. So dimensions, we can put that this one's height, this one's width, and this one's length. So that represents the volume. Now we're going to put height equals 20.0 centimeters, weight equals, or not weight, I'm sorry, width equals 8 centimeters, and then length equals 0.350 centimeters. And we also have this last number here, the mass. So mass equals 636 grams. We're going to divide this, and then we're going to get our required. What the heck are they looking for? So it says calculate the density. That means that's our required. So density. We don't know what the number is, but it says we have to calculate it in these units. Grams over centimeters cubed. So now that we have all these numbers, what was the formula for density? So what was the formula for density? Remember that density equals mass over volume. So this is what we're looking for. We don't know what it is yet. We do have the mass, which is 636 grams. And believe it or not, we do have the volume too. Why? Because all we have to do is multiply these three things together to get the volume. So 20.0 centimeters times, let's go to the right, 8.0 centimeters times 0.350 centimeters. All right, let's multiply all of that. So we're gonna calculate what's in the denominator first. So 20 times 8 times 0.350 equals, so all of that, or all of this down here, equals 56. Let's go to the right. So all of this equals 56 centimeters. And we're going to put cubed. Why? Because here, 1, 2, and 3. So if this were to be alone, it would be just centimeters. If these two were to be together or multiplied together, it'd be squared. Now, if all of them three are multiplied, then it's centimeters cubed. All right, now we're going to pass this on. So 636 grams over 56 centimeters cubed. If we take out the calculator once more, so 636 divided by 56, we have 11.36. So 11.36, and the units, remember, units are important, so we're going to keep those. Grams over centimeters cubed. And you're done. So the density of the block of lead was 11.36 grams cubed. Or, I'm sorry, 11.36 grams over centimeters cubed. Now, the last question, which is all the way down here. Explain the differences between intensive and extensive properties. So, intensive properties, remember, intensive properties, they do not depend on the amount of substance, but extensive properties, they do depend, or they do change with the amount of the substance. Remember what were a couple of examples? So for intensive properties, we had color, we had density yet again. For extensive properties, we have mass, volume, and length. And that's it for the lesson. Thank you.